Hey guys, what's going on? Welcome to this Maths Methods help video or chapter help video, whatever you want to call it. This is going to be on chapter 1A, which is the first chapter of the textbook. And it's on linear equations or solving linear equations or finding the unknown variable, whatever you want to call it. Now, this video is going to assume that you've done the Year 10 Maths and have a good understanding of basic algebra, and this chapter specifically, it's pretty easy. It's one of the easiest chapters in Maths Methods Unit 1-2. So let's get straight into it. But first, we want to define what a linear equation is. This is going to be very brief. I've written a definition here. So any equation where the unknown variable is to the power of 1. That is my definition of a linear equation. So any equation, that means that the problem must have an equal sign, and then this other part, where the unknown has to be a power of 1, the unknown variable that we're trying to solve needs to be to the power of 1. It cannot be squared, it cannot be to the power of 3, nothing like that. So what this means is x to the power of 1, that means it's linear, okay? Or x to the power of 1 is the same as just x. It's the same thing. You can cancel out the power of 1, just like remove the power of 1. However, x to the power of 2, or x squared, is not linear. So because it's to the power of 2, it has a power, which therefore eliminates it from this definite. It's invalid when we consider this definition. All right, so let's go into solving linear equations, which is what the chapter is about. So the first type of equation that you're going to encounter in this chapter is going to be when x is on one side and you're just trying to solve for x. So in this example, 4x plus 3 equals 11. We want to collect large terms and then make it so that x equals something. So what we're going to do is just simply rearrange the 3 over to the other side. So 4x equals 11 minus 3, which is equal to 8. And then we can simply just divide both sides by 4 to get us the answer of x equals 2. Pretty simple. You should know this from Year 10, maybe even Year 9 or Year 8. Now here, this next type of linear equation that you're going to find in this chapter is going to be when x is on both sides of the equal sign. So in this example, we have 4x plus 7 equals 7x minus 2. Again, the same principles as the first example, in which we're going to rearrange the equation so that we make x equal something. So we bring, we can do this like either way. So bring the 4 over to the other side, or bring the 7x over to the other side. Doesn't really matter. So what I like to do is make sure the variable, or the coefficient of the x variable, I like to make it positive, so we don't have any like negative numbers. I don't really like that. So what I would do is bring the 4x over to the other side, so that becomes 3x minus 2 equals 7. Because we've just transferred the 4x over to the other side. And then here we can do 3x equals 9, and then simply divide both sides by 3 to get us x equals 3. Pretty simple. Now the next sort of type of linear equation that you're going to find in this chapter is going to be with brackets. So again, brackets, nothing too crazy, nothing too scary. We can kind of solve with two methods. The first method is we get rid of whatever is in front of the bracket. So in this case, we have x bracket 5x plus 2 end bracket equals 48. Now what we can see is 8 and 48. The highest common factor of them is 8, so we can simply just cross this one out, the 8 here. So that becomes 5x plus 2. See, we've eliminated the 8 here, so there's no brackets, nothing in front of the brackets anymore. But we also need to divide the other side by 8. So that means 48 divided by 8, which is 6. Okay? Pretty straightforward. Now it's the same as the first example. We just make it so that x equals something. So 5x equals 4, x equals 5. Oh, sorry, 4 on 5, not 5 on 4. 4 on 5. Pretty simple stuff. You can write it in decimal form if you want. It doesn't really matter, but I suppose like fraction form's probably a little bit better. We work with fractions a bit more in Maths Methods Unit 1 and 2, especially later down the line. So it's best to keep your answers in fraction form. That's through my personal experiences, but yeah, it doesn't really matter. You can ask your teacher and see how that they would see what they would advise you to do. Yeah. Now, the other method you can use is to first expand the brackets, then rearrange the equation so that you make x equal something. If you follow this method, you'll get the same answer of 4 over 5. And then we get to our this is not really the last form of linear equation, but this is where we see fractions. And fractions, again, nothing too crazy or scary, so what we're going to want to do here is find the lowest common multiple of all of the denominators, which in this case is 8, and then make that the new denominator for all of the numbers. So make 8 the new denominator for all of the numbers. This is how we're going to do it. 2x minus 5 plus x plus 2 equals 3. Now the reason why they don't have a denominator is... Hold up, that's not correct. The reason why they don't have a denominator anymore is because we've made it so that they share a common denominator. Basically what this is saying is that over 8, that over 8, that over 8. And since they share the same denominator, we can just cancel it out. It doesn't really matter. We can cancel it out. It's just taking a bit too much space. It's becoming a bit too messy. So yeah, we can just cross them out, eliminate them. So again, 2 bracket x minus 5 plus x plus 2 equals 24. Again, we can expand the brackets now and then solve for x. So pretty simple stuff. 2x minus 10 plus x plus 2 equals 24. You can rearrange the equation, make it so x equals something. So what we do for our next step is going to be 3x equals 24 plus 10 minus 2, which is going to be 16. Yep, 16. Is it? Yes. No, it's not 16. Hold up. That's going to be 32, not 16. We're not subtracting time. Anyway. And then from here we can just do x equals 32 over 3. We got there in the end, but pretty simple stuff, right? And yeah, those are the kind of types of equations you're going to find. There is one more though, and this is going to be literal equations. So an example would be probably x plus b over a equals b plus a. Where do we write that? B plus a. So those are literal equations. What this means is that there are no numbers, or sometimes there can be a mix of numbers and letters, but some of the time there's going to be just letters or variables, no numbers or anything, so you can't really get an exact figure or number as your answer. The best way you can solve these sort of equations is by rearranging it so that x equals something. Again, this is like the most important principle when you're trying to solve for linear equations. Make it so that x equals whatever, whatever, whatever. So here's how we're going to do this question. Rearrange it so that the first way we're going to rearrange it is bring the a over to the other side. So x plus b equals a, b plus a. You can expand it if you want, and then we can just bring that b over to the other side. So x equals a bracket b plus a n bracket minus b, which is the same as ab plus a squared minus b. X equals that. And that's your answer. You can't really do much with this answer. You can't really simplify it. But it's as best as you're going to get. It's better than whatever this is, because we have x equals something. And yeah, those are going to be your 4 or 5 types of equations you're going to find in this chapter. Pretty straightforward. It's just like a little refresher from year 10, year 9 maths, so on and so on. If something doesn't really make sense, you have a question, drop them down in the comments down below. If you did enjoy this video and found it very helpful, make sure to give it a like. Make sure to subscribe, and I'll see you guys in the next one.